physicist at the Conservation Fund's Freshwater Institute. We're in West Virginia in the United States. I'm coming to you from my home office. We're working primarily remotely with some essential employees that are going in to keep our research operating at the Freshwater Institute and to take care of fish and our general operations while we social distance and take safety precautions. First, I'd like to thank Annex Business Media and the folks that have arranged this webinar, Mary Lynn, Jean, and Anna, and everyone else. This is a great opportunity for us to share our research at the Freshwater Institute. Otherwise, there are obviously limited opportunities this year due to the virus. So thank you very much for this opportunity. The Freshwater Institute has 7 presentations that we'll be delivering during the webinar on topics ranging from RAS production of Atlantic salmon, water quality procedures that we use on site, fish health and waste management research, and our upcoming precision aquaculture initiative. My presentation today is based on standard operating procedures to remediate off flavor from RAS-produced Atlantic salmon. First, I'd like to thank my on-site co-authors and Freshwater Institute colleagues that participated in this research, including Steve Sommerfelt, who is now with Superior Fresh. And then I'll recognize other co-authors during my presentation that have contributed to specific projects throughout. So I wanted to start out with just the format of my presentation. First, I'll begin with discussion about just the basics of off flavor and RAS. I think most of you that are tuning in that are involved with RAS are aware of off flavor issues. It's not a secret. This is something that we've been working on for over a decade. And so the first part of my presentation, I'll go back to some of the original research that we carried out in collaboration with our USDA partners. I'll move through some of the additional projects that we carried out to fine-tune our depuration procedure, some of which we recently published in Aquacultural Engineering. And we used all that research to develop our own standard operating procedures for purging Atlantic salmon at the Freshwater Institute. So I'll be going through some of the procedures that we use, and then finishing up my presentation with discussion regarding future research and other possible solutions to solve the off flavor problem immediately in the RAS production system. So just to start out with some background, most of the land-based RAS facilities out there are challenged by off flavors that bioaccumulate in fish flesh. The 2 primary compounds that are of concern are geosmin and 2-methyl-isobornyl, commonly referred to as MIB. These are metabolites of bacteria that persist in biofilms and generally in aerobic oxygenated zones of RAS. These compounds can also enter RAS facilities or any aquaculture facility for that matter via the supply water. These compounds create earthy, musty taste in fish flesh that are unacceptable to consumers and eventually could result in rejection of product at the marketplace. So this would be catastrophic for a RAS producer to go to the extensive effort and investment that it takes to grow a market-sized salmon, and then to lose that product due to rejection. It generally takes about 2 years to grow an Atlantic salmon to market size, so there's a lot of loss that would be associated with a rejected product. With that said, the last 5 to 10 days before harvest are critical. This is when a RAS facility needs to be carrying out finishing steps to ensure that they have an all flavor free product, a premium product that consumers will enjoy and will come back and purchase again. So I wanted to first talk about some of the original research that we collaborated on with our colleagues at the USDA ARS. Gary Burr was the lead author for this work that published in Aquacultural Engineering in 2012. And really, this original research set the standard for purging all flavor from RAS-produced Atlantic salmon. The primary finding was that we need to remove the Atlantic salmon or other fish for that matter from the RAS into a separate depuration system. And then it usually takes up to 10 days or possibly beyond that to purge all flavor in these separate odor-free flow-through or RAS or partial reuse systems. Another important finding of this study was that extended depuration resulted in relatively significant weight loss, reduced fillet color, and lower lipid levels in the fillets. And I'll come back and talk a little bit more about this later, but there are economic implications to these product quality losses. So at the Freshwater Institute, we followed up on the original Burr et al. Study with our own on-site research. This published in 2014 in Aquacultural Engineering. We collaborated with co-authors at the Lacombe Research Station in Canada and other USDA ARS colleagues. Essentially, this was a 2x2 factorial study, with the two factors being disinfection of our depuration systems before stocking fish and absence of water aeration media in our gas conditioning columns. So in a nutshell, what we found was that when we pre-disinfected systems with hydrogen peroxide and when we excluded water aeration media from our gas conditioning columns, we had more effective off-flavor remediation. So if you look at the photo in the upper right-hand corner, you can see an example of what that media looks like. It's plastic media with high surface area. And the reason that it's an advantage to exclude this media is you can tell that it also would create high surface area for biofilm accumulation and potential shielding of off-flavor bacteria that would otherwise be disinfected. So we have applied the things that we've learned from this project to our current standard operating procedure at the Freshwater Institute. So more recently, we were fortunate to receive funding from NOAA Sea Grant program. This was a collaborative project with Greg Fisher at the University of Wisconsin-Stevens Point. Greg led this proposal, and Steve Sommerfeld was involved at Superior Fresh, and we worked with Casey Grimm at the USDA ARS for off-flavor analysis. We were responsible for two depuration experiments. The first was evaluating the effects of flushing rate and associated system hydraulic retention time on off-flavor remediation from market-sized salmon. And I've listed the various hydraulic retention times that we tested during that study. The second study, we evaluated effects of variables that influence Atlantic salmon metabolism with a 2x2 factorial study, where the factors were dissolved oxygen concentration and fish swimming speed. And the reason that we specifically studied these two variables was that they could potentially have an effect on gill ventilation rate and the ability of the fish to rapidly excrete off-flavor. And I'll talk a little bit more about that in the upcoming slides. So for each of these studies, first we wanted to make sure that the fish accumulated enough off-flavor that we were carrying out a relevant study. Sometimes we have off-flavor in our fish, and other times we have lower levels. So we first dosed the fish in a common partial reuse tank with concentrated geosmin that we purchased from Sigma Aldrich. So the plot at the upper left-hand corner shows this procedure in action. So we added the concentrate to the system, and very rapidly the Atlantic salmon uptook that geosmin and absorbed it into their flesh, with 80% of the off-flavor being accumulated in just a 4-hour period. Following this off-flavor geosmin dosing period, we randomly stocked the fish into 12 replicate partial reuse systems that you see in the picture at the bottom right-hand corner to begin the study. So these are some of the results from the study where we looked at the three different flushing rates. Again, this was a study comparing geosmin remediation and partial reuse systems operated with 2.4, 4.6, and 11.3 hour hydraulic retention times. And we sampled water across that a 10-day depuration period. And we found that hydraulic retention time affected geosmin removal rate. And you can see a really nice stepwise reduction of off flavor in the water between these different hydraulic retention times. So what's happening is that fish are excreting off flavor into the depuration water, and the water flushing rates that are passing through these systems are carrying that off flavor out of the systems until that water finds equilibrium with the concentration of geosmin that is inherently in the makeup water. And you can see that happening in the plot. I should point out here that we generally don't measure detectable MIB in the system, so I'll be focusing on geosmin throughout my presentation. So the next slide here shows geosmin levels in Atlantic salmon flesh in the same study. So you can see that we effectively boosted the geosmin in the salmon flesh up to over 1,000 nanograms per kilogram to begin the study. But subsequent to that, the salmon effectively purged that geosmin from their flesh. So I've zoomed in on days 3 through 10 so that you can see the standard error bars. At day 3, we didn't have any significant differences between our flushing treatments, but by day 6, the Atlantic salmon in the 2.4-hour hydraulic retention time treatment had the lowest residual off flavor remaining, and we had differences between each treatments. By day 10, the off flavor was similar in the 2.4 and 4.6-hour hydraulic retention time treatments, and significantly higher in the 11.3-hour treatment. I should point out here that we believe that fish in all these treatments were effectively purged by day 10. There is not a wide range of information out there about the human sensory threshold of geosmin in Atlantic salmon flesh, but based on anecdotal information we've collected at the Freshwater Institute, we believe that all these fish would have been purged in the various treatments, but with some treatments resulting in faster remediation of all flavor than others. So this was information that we gleaned from a study that we recently published in Aquacultural Engineering. It was just a month ago this paper came out. It's publicly available as open access. And there were some other details that we presented in this paper that I'll quickly highlight. Obviously, rapid water flushing effectively remediated all flavor from RAS-produced Atlantic salmon. In communication with a colleague in Israel, Mr. Snir Azaria pointed out to us that 1,000 liters of cumulative water flushing generally per kilogram salmon biomass generally results in optimal depuration. This is something that's not entirely proven, but if we look at our various studies, this water flushing rate per biomass ratio seems to work out each time. With that said, that amount of water is a relatively large volume of water, particularly when we start to consider commercial scale facilities. So later in the presentation, I'll talk a little bit more about that, and we realize at the Freshwater Institute that may be something that we need to look at a little bit in more detail through our research, reduction of water use in depuration systems. Another thing that we highlighted in this paper is that in the big picture, a RAS producer wants to take the necessary precautions in terms of pumping enough water to effectively remediate all flavor from Atlantic salmon flesh. With this in mind, rejection of just one cohort of salmon would far outweigh any water pumping expenses that are associated with depuration. And then I want to highlight again this need for additional research relative to the human sensory threshold for Atlantic salmon and maybe other species that are raised in RAS. There's a little bit of information out there in various studies that I have included here in the bullets. And I have seen some anecdotal information presented by others that shows that 200 to 250 nanograms per kilogram may be an effectively purged fish. But for safety and precaution purposes, we generally purge our fish to the lowest residual off flavor concentration that we can achieve in our purge systems. So the results that I have presented on this slide are for the second Sea Grant study, looking at the various factors that could influence metabolism of Atlantic salmon and more rapid excretion of all flavor. Unfortunately, some of the complexities of COVID-19 have limited our ability to finish the laboratory analysis of this particular study. So I'm only presenting here what we have back so far. I also want to point out that we were focused on swimming speed, and we found that it was very difficult to effectively swim a fish near 1 body length per second that is approaching 30 centimeters in length, a market size Atlantic salmon. So we had to settle with slightly lower body lengths per second, 0.6 and 0.3. And the other complexity related to looking at oxygen is that when fish are stocked in these depuration systems, they're not being fed. So it was also difficult to create a large gradient in dissolved oxygen concentration. So we looked at 100% saturation and 90% saturation. So the results that we have back thus far are quite opposite of what we would have expected. We hypothesized originally that the faster that you would cause a fish to swim, the faster that all flavor would be remediated. And so far, the data indicates that that's actually the opposite here. And what I think may be happening is at the really low swimming speed, 0.3 body lengths per second, that the fish are actually being forced to swim forward and to ram ventilate and to use their gills more in that scenario. So the data thus far shows that the fish that were forced to ram ventilate were potentially remediating all flavor at a faster rate. So with this slide, I wanted to go back in time a little bit. This is some data that we never published. We have presented it at various conferences. This data kind of harkens back to my statement about potentially reducing water in purge systems. So what we did with this particular study is we carried out a 2x2 factorial experiment where one of the factors was treatment of our supply water with granular activated carbon or not, and then pre-disinfection of depuration systems with hydrogen peroxide or not. And very interestingly, when I look back at this data, I see that the geosmin level in the depuration system water was the lowest when we pre-disinfected and we treated our makeup water with granular activated carbon. And those same data show up in the fish flesh. We didn't publish this data because we had relatively wide standard error bars that prevented any definitive conclusions. But given some of the feedback that I've had recently from stakeholders, I would say that we may want to revisit this, and even a RAS producer could consider incorporating granular activated carbon immediately in the recycle loop of a depuration system, and they might get some positive results for all flavor remediation, and while reducing the amount of water use that they are using in the systems. So the last piece of research that I wanted to share, we also have not published, but my colleague Travis May is working on various communications of this data, and we have plans for an eventual publication on this. So in the early research that was published by Burr et al., they showed that fish have some degree of weight loss during the depuration procedure, particularly as it extends more and more days. But their research was carried out with relatively small salmon that were 2 to 2.5 kilograms. So we evaluated similar metrics with market size Atlantic salmon. So the data that you see presented here is percent loss of a head-on gutted product, and we're presenting the day zero data of a fish that has not been purged, but it has been processed. So you can see that across the board, we have some almost equal degree of weight loss that is associated with processing. That is the visceral loss and the blood loss. But once you get to day 6 and beyond, there's an additional weight loss that is happening in the carcass of the fish. At day 6, it's 2.1%, day 10, 3.5%, and at day 14, 4.2%. So for now, we're calling this an unexplained loss, but we hypothesize that it has something to do with loss of either lipid, protein, moisture in the carcass, or some combination of these variables. And this is another example where we have samples that are out at a laboratory, and we just have not been able to get that analysis back yet. So what this means in the big picture is that the longer that you have to purge fish, you could potentially have a weight loss, which is a relatively low percentage. But when you equate that on a commercial scale, for example, a 5,000 metric ton facility, this could potentially result in $1 million weight loss. $1 million of revenue loss, and that extends to greater loss as the commercial size of a facility increases. So I wanted to wrap up with some of the key points and take-home messages from the various research projects. Again, we found that rapid water flushing, 2.4 to 4.6 hour hydraulic retention time achieves optimal off-flavor removal. The 11.3 hour HRT was also effective, but it took a little bit longer, out to 10 days, to achieve a purged fish. We hypothesized that variables associated with fish metabolism, including swimming speed and dissolved oxygen levels, could speed the rate of off-flavor excretion, and we look forward to getting back our full data set on that to share with stakeholders. And I just talked about the potential implications of weight loss if you have a longer depuration period. And at this moment, we still believe that site-specific depuration procedures must be adopted and strictly followed by land-based RAS facilities to produce an off-flavor premium product. So all of this research, we've gleaned a lot of information from. And we've taken what we've learned and we've applied it to our own procedures at the Freshwater Institute for depuration. So we go through a preliminary protocol, and that protocol includes draining the system volume, power washing and cleaning all system surfaces and components. We then refill the purge system. We disinfect with 200 milligrams per liter hydrogen peroxide, as you can see Curtis doing here in the picture at the right, using safety precautions. And then we flush that residual peroxide from the system, and then the systems are ready to stock fish. Our team recently put out a really nice YouTube video that walks you through the step-by-step procedure that we developed at the Freshwater Institute. And I've included a link here so that folks can visit that and see how we approach depuration. So obviously the next step in the procedure is stocking fish into our depuration system. The picture at the top left-hand corner shows two of our team members that have crowded Atlantic salmon in our semi-commercial scale RAS, and they're quickly and easily moving those fish out of the system through the side box and through a black corrugated pipe that empties those Atlantic salmon immediately into our depuration system with minimum stress and handling. So some of the basics of this procedure, we're fortunate to have very clean, relatively low off-flavor concentrations in our supply water, and that's an important component of our effective depuration of salmonids. We keep the fish off feed in our systems. Obviously, 2 to 3 days are required at minimum just to clear the gut prior to processing. And then we also think it's important to keep the fish off feed so that we have clean water that does not accumulate organics that could promote off-flavor producing bacteria. Generally, we operate with a 6-day purge cycle to remediate off-flavor, and we've never had any complaints from the folks that we have distributed our salmon to, and from the various chefs that have tried our salmon. So this slide shows the basic design of our partial reuse systems that we use for depuration. It's purposely a very simple design that has limited piping, limited surface area that we learned from before in our research. So we don't have aeration media in the gas conditioning column. We simply just have a fish tank, a pump in the sidewall box of the tank that sends the water through the column to add oxygen, to strip carbon dioxide and nitrogen gas, and then the water returns to the fish tank. We've always used a 2 to 3 hour hydraulic retention time, and the research that we just carried out validates that approach for the most optimal flushing of all flavor from our fish. And again, we use a 6-day purge cycle. So the next part of my presentation, we'll talk a little bit more about in-RAS procedures that could potentially be used to mitigate off flavor. Again, there's not a specific procedure that I know of that has been proven to always effectively remove off flavor, particularly in relevant scale RAS or commercial scale RAS. But first, I wanted to talk about a project where we tried an out-of-the-box approach in some of our replicate reuse systems. So what we did is we stocked native freshwater snails that are present in our makeup water supply. These snails always tend to make their way into our system, so we're not concerned about them spreading a virus or carrying a virus into our systems. And they tend to like the conditions of our RAS. So the picture at the bottom right actually shows the snails creating jelly egg masses and reproducing in our systems. And if you look closely, you can see some juvenile snails. So we carried out a project with and without snails in reuse systems, and we published this research several years ago in the Journal of Applied Aquaculture. And we really found some interesting results. The picture at the top right-hand corner shows the wall of a pump sump that contained the snails, and the snails consumed almost every bit of biofilm that would have otherwise accumulated in those systems. The picture at bottom is a pump sump that did not contain the snails. And we purposely didn't clean, but we accumulated a relatively large amount of biofilm in these systems. So you can see the dramatic effect that the snails had. We also had lower levels of heterotrophic bacteria counts in the water. And obviously, when we scraped the walls, we had lower solids that were associated with biofilm. And in some cases, we had lower levels of off flavor producing bacteria in the biofilm. However, the fish still accumulated biofilm, or they still accumulated geosmin in their flesh. We had trends that indicated lower geosmin. However, we didn't have significant differences. We hypothesized that the reason that we didn't have any greater dramatic effect is that the snails were only held in the pump sumps and didn't proliferate throughout the systems. So there have been other attempts and other waste treatment procedures and technologies that have been attempted in order to remediate off flavor in the immediate RAS production system. Jaap van Rijn has shown that organic rich anaerobic zones of RAS, such as denitrification processes that contain sludge, can absorb off flavor compounds. I've also read about research that shows that batch dosing of peracetic acid can result in lower concentrations of off flavor. And there's a range of other technologies that have been looked at, such as I've heard from stakeholders that high dose ozone followed by UV could potentially be effective. However, at the Freshwater Institute, when we have used only ozone, we have not seen positive results for off flavor remediation in our primary RAS. And I've listed some other work that has been carried out to look at off flavor remediation in the immediate RAS, but as I previously mentioned, there currently is no effective solution that I know of that consistently remediates off flavor in the primary production system. So I've included this particular schematic to demonstrate why it is difficult to remediate all flavor in a RAS. There are many different unit processes and pipes and locations in the RAS that all flavor producing bacteria can populate, biofilms can grow, including inside of pipes, on the walls of the various tanks and sumps, and even inside of the biofilter. So you can imagine that if you're trying to remediate all flavor in one location of the RAS, that you still could have production of all flavor and growth of all flavor producing bacteria in a completely different section of the RAS. So I believe this is one of the key elements that has made it difficult to remediate all flavor in the primary production system while feeding fish. So just a recap of some of the key conclusions and practical take-home messages from this research. Depuration in separate biofilm-free systems with rapid water flushing is still the proven standard for all flavor remediation and what we recommend at the Freshwater Institute. We do think that continued research is necessary in order to reduce the duration of the purge cycle and to develop techniques that reduce water use in depuration systems. And I didn't specifically mention this in other slides, but we think that it's very important for prospective RAS facilities to test their supply water to determine whether they have inherent all flavor in that supply water. Otherwise, it may be very difficult to remediate all flavor in the depuration system. And I've talked about some of the possible technologies and strategies that are out there that are being researched to eliminate all flavor in the primary RAS. And obviously, this would be the holy grail for the industry to establish a procedure that we are confident in that can accomplish that. So all of that said, RAS-produced salmon has a tremendous upside. You can just look to the news to see the many different facilities that are coming online or being planned currently. There's tremendous momentum that's taking place with RAS. And I've also heard rumors that the COVID-19 pandemic could be influencing the need for RAS in the future as domestic, local, and fresh product become more important. But I can't emphasize enough that we're not only growing Atlantic salmon in our RAS production systems, we're trying to create a quality product that tastes great, that is a premium product, and that RAS producers must establish procedures to ensure that they have a product that consumers enjoy and want to purchase again. So I just wanted to wrap up with some acknowledgments. Thank our funders for the various research projects, the USDA ARS and NOAA Sea Grant. And I also wanted to recognize some of the behind the scene folks. I mentioned a lot of our co-authors for the various research projects, but we have a lot of folks behind the scenes that are contributing to the research that we publish and present on, including water chemistry staff, operations staff, and folks that produce our CAD drawings and photography that we use in presentations. So thanks to all those folks. And just wrap up with potentially a shameless plug here that all of our research articles that we publish are available at our website, and I've included a link here so everyone can go to our website and open those articles free of charge. And finally, the picture at bottom right is a photograph of our relatively new research facility where we're carrying out a lot of contract research in addition to our publicly funded research. And we are open to working with private stakeholders to answer some of these important questions that remain about depuration and all flavor remediation. And I've included my contact information on this last slide since this is a much different venue remotely. The most effective way to reach me right now is through my email if you have any other questions. So thank you very much for tuning in, and thanks again to the folks at Annex Business Media for sponsoring this webinar. Thank you very much.